So this problem, we are looking at a system of linear equations, and we're going to solve it by elimination. So there are two ways that you could do this. One is by substitution. This is by elimination. So our goal is to eliminate one of the variables. And so what we're going to do is look at these two linear equations and find the variable, either x or y, that has different signs. Now, this may not always happen this way. This method requires a little bit of working with sometimes to get some variables that will easily eliminate or cancel out. So this particular set actually is pretty easy because we can notice that this y is positive and this y is negative. So now that we know that y is our variable that has different signs, this is the variable that we are eliminating. And so in order to do that, we're going to add the two, and that's supposed to say TWO, two equations together from top to bottom. One of the variables should cancel out. Okay, if that doesn't cancel out, then there's some more work you have to do, and I will show that on the next example. So all we're going to do here is just add top to bottom, add these two up. So we've got negative 4x and negative 5x. That gives me negative 9x. And what happens here? Y minus y, that just eliminates. That goes away. And then 6 plus 21 is 27. And we divide both by negative 9. And we get x is negative 3. Okay? Once we have one of the variables, it does not matter which equation we choose to plug it back into. So we're just going to substitute this x equals negative 3. I'm going to just go ahead and put it in this first one. So I have negative 4x plus y equals 6. And this negative 3 is going to go right there. So negative 4 times negative 3 plus y equals 6. And we're just solving for y here. So this is 12 plus y equals 6. And minus 12. Y equals negative 6. And remember that a solution to a system of equations, if there is one, is written as an ordered pair, because this is the ordered pair in which it makes both the x and the y make both of these equations true at the same time. It's where these two graphs intersect. So my solution here will be the ordered pair, the point negative 3 comma negative 6. Now I want to show you real quick, this was one that was fairly simple. When we added, this canceled out, the first step worked out great. They don't always work out that way. So let me show you what happens if it's a little bit different. Okay, so I have another problem here. 2x plus y equals 10, 3x minus 2y equals 15. So notice that I have a variable here that does have different signs. So this y is positive, this y is negative. So y is going to be my candidate for elimination. But the problem is, if I was to add these two up, I would have y minus 2y, and that would give me negative y. And that's not going to work out so well because I need this to eliminate. I need this to cancel. So what could I multiply this y by in order for this to cancel? And we know that that's 2. And the key here is you can't just multiply that 2 on that y. You have to multiply across the entire equation. So it's kind of that whole concept of whatever you do to one side, you have to do to the other. So we're going to multiply all of this and this by 2. So this is going to give me a new system of equations. And this is a completely legal operation. We can multiply any number on this equation, but it has to be all the way through. So every single one of these terms in this first equation has to be multiplied by this number. Okay? So 2 times 2x would give me 4x. 2 times y would give me 2y. And 2 times 10 would give me 20. So I have an equivalent equation here. I haven't really done anything as far as changing the values of what the solution would be, because I multiplied everything by the same thing. All right, let me carry this one over. 3x minus 2y equals 15. And now we see that they have the same coefficients but different signs. So now we're set up to add these two together so that they will, one of these will eliminate, and our y variable is eliminating in this example. So 4x plus 3x is 7x. 2y minus 2y cancels. 20 plus 15 is 35. Divide by 7, and I get x equals 5. So again, don't stop there. You do have to go back in and solve for y. So if x is 5, it does not matter. Pick one of these and plug in 5 for x. So I'm just going to take this first one again. 2x plus y equals 10. And I'm telling you right now I'm doing this because I don't have to divide anything out once I move the x over. So we're going to multiply here and plug in 5 for x. So I've got 2 times 5 plus y equals 10. So here I get 10 plus y equals 10. And subtract 10. And I get y equals 0. So don't panic. Don't panic. One of the variables could actually have an answer of 0. What would that point be? What would that point be here? What would our solution be? So our x value is 5. Our y value is 0. If you think about graphing this, you can certainly have a 0 answer, and for the x or the y, and maybe even for both, because this particular point, 5, 0, is on the x-axis. So this would be the x-intercept, 5, 0. That would be the x-intercept. So this is totally okay to be an answer. 0 can be one of the variables or both. And this solution is 5, 0 to this set. So these two do cross, they intersect at this point. So just keep in mind that if you have a variable here that has different signs, but the coefficients are different, you have to multiply one of the equations by some number so that you're getting coefficients that are the same but signs that are still different. And that was solving a system of equations by elimination.